All right, this video will go through how to compose two functions to obtain another function. So sometimes in math, we want to use the output of one function as the input of another function. So we'll start by evaluating some, say, g of x, and take the answer that we get and plug that into f of x as the new input. And we call this composition when we do this. And the way we generally write that is this sort of setup. So you put g of x inside of f, and we read that as f of g of x. Sometimes in some books or just in other places, you may see this notation, but this means exactly the same thing. Okay, this little circle here is called the composition symbol. We are generally not going to use that, but you might see it in like a homework problem or something. So just to be aware of it. And the order does matter. Okay, so if I put g of f, we're going to see that a lot of times that will give me a different result than f of g. And like everything in pre-calculus, we want to be able to do it with a table, with a graph, and with an equation. Okay, so we'll go through those examples. So this would be an example of a question you might see. You would get two tables, one for f and one for g, and be asked to evaluate f of g of 3. Right, well, make the problem simpler. Okay, start on the inside, like we'd always do with parentheses, start at the middlemost thing. If I just asked you to do g of 3, you know that would be plugging in x is 3 and getting out a y coordinate. Okay, so you would go to your table, okay, when x is 3, y is 2. So g of 3, we can replace that with just 2. And oh, okay, f of 2, I know how to do that. Go to my table, and the answer is 8. Okay, same thing for g of f of 4. Now we just need to go the other way. Okay, so f of 4, I would go to my table and get 1. And then g of 1, of course, would be 3. You can compose a function with itself. So you could do like f of, let's say, 4. And you would just, do the same thing twice. So you would go, okay, f of 4, that'd be, well, we just found that was 1. And then just do it again. F of 1, right, would be 6. So you can compose f with f or g with g. You can also, we're not going to do an example like this, but you could do, like f of g of f of whatever, and you could just keep going and keep building. Or you can compose as many times as you like. And one other thing that can happen sometimes when you're composing with tables, so let's see, let's make this work out. If I do like f of g of 4. So you would look at the table, g of 4 is 7, but f of 7, right, I don't know. That's not in my table. So we would simply say that that is undefined. Maybe it has an answer, but based on the information that we have, we don't know. So that's the best we can say. All right, so that's doing it with a table. We should also be able to do it with a graph. So here you're presented a graph of f and a graph of g, and you're asked to find f of g of 3. Well, we're going to do the same thing. It's just instead of looking up in a table, we're going to go look on a graph. So g of 3, again, that's the x coordinate. So we would go over to our graph and find the y coordinate, which in this case would be 4. And then do the same thing, right? Go over to our f graph, and it turns out when x is 4, f is 0, right? It's on the x-axis. And then we do the same thing for, right, if I do g of f of 1, well, f of 1 would be, in this case, looks like 3. And just round off to the nearest whole number if you're doing this on like a test or something. And then g of 3, we would go over, and we actually know that from before, is 4. All right, so nothing too tricky about these. You just sort of need to know what the symbols are telling you to do. All right, and finally, with an equation. Okay, so we're presented two functions. Okay, f of x is 3x squared plus 5x plus 4, and g of x is 2x minus 1. And we're asked to evaluate three different things. So the first one is familiar, okay, f of 2. Okay, we know we could go up to our function. We all know what that means from what we've been doing before. Right, and then we would just need to get what that's going to come out to. So let's see, this will be 12 and this will be 10, so 26. And then, right, so we know this is going to be g of 26, and then we would go ahead and plug that into the equation for g. And that's going to be, 52 minus 1 is 51. Right, so in that case, we end up getting a number just like we did, when we did it with a graph or with a table, right? Our final result was a y value. Sometimes what you'll be asked to do, though, is actually compose the functions in terms of x. So g of f of x, right? Let's think about what that means for a minute. So, g of 3 would mean plug in 3. Right? So where there used to be a x, put a 3 instead. Okay, so what we're going to do now is just g of f. So let's take the original function for g, right, 2x minus 1. But where there used to be an x, let's put a set of parentheses. And into those parentheses, I should give myself more room, we're going to put f of x, right, the whole equation. Okay, so rather than substituting a number like we did with 26, we're going to substitute an entire equation. And then you should simplify. Okay, usually like on a test or something, it's going to ask you to simplify that. So we would distribute the 2. Okay, so, and at this point, it's just doing some algebra. And don't forget to include the minus 1 at the end. And you're done. Okay, that is as simple as it gets. You don't need to try to factor that or anything. In fact, factoring would kind of make it less simple. So in this case, our final answer is another function, right, an equation, instead of getting a number like we did before. And then like we said before, the order does matter. So if I do f of g, okay, so what I'll do is I'll take the function for f. Some students find it helpful to think of it this way. Right, wherever there used to be an x, I'm going to blow that up and put parentheses instead. Wherever there used to be an x, put a set of parentheses. And then into those parentheses, put the equation for g. Now this is going to take a little more algebra, but we would go ahead and simplify that. Okay, so first I need to square the 2x minus 1, and remember that's really like doing this, right? If you need to do it out, that's fine. But that's going to be 4x squared, let's see, minus 4x plus 1. And then, right, we can go ahead and distribute this 5. And, at this point, it's just a lot of algebra, but we'll get there. All right, and then combining like terms, and I'll do it up here because I'm out of room. 12x squared, let's see, that'd be minus 2x. And then let's say plus 3 minus 5 would be negative 2. So plus 4 would be positive 2. Right, and that is our final answer. Okay, so you can see that the order matters, right? You get different results. So be careful when you're doing it, which one goes into which one's the inner function, which one's the outer function, right? That matters. All right, one last thing is what we sometimes call decomposition. Later on in calculus, you will encounter something known as the chain rule, and it will be important to recognize what we call the outer function and the inner function. and to sort of break it apart into two functions composed together. So looking at this example, okay, it says write this function as the composition of two functions. Okay, so for instance, let me just give them different names. We want f to be g of h of x. Okay, so we want to come up with some function g and some function h so that when I put them together, I get back where I started. Okay, now there's a few different answers. There's multiple ways to do this. But looking at this, I would say let's let g be this, and let's let h be this. That would be my answer. And we can see, right, g of h, that means everywhere there used to be an x in g, we're going to replace it with h. And you can see that that would get us back where we want to be. Now that's just one example. Okay, so to show you another example, another way you could have answered this question, let's say, g of x equals 3 plus x, and h of x equals the square root of 5 minus x squared. Okay, that'd be another way to answer it. And we can see, right, if I took that and plugged it in here, it would get me back where I started. Okay, so for something like this one, okay, now read the directions. They want us to have h of x become f of g. Okay, so like f is sort of the outer layer, and g would be the inner layer. So looking at this, okay, my outer shell is this squared thing, right? I need to square something. So what I'll do is let this one be x squared, and let the inside be the x plus 2. And I can see if I put the x plus 2 into the squared, I end up back here. Okay, and there's certainly other ways you could do that one, but that's probably the easiest way. And then this last one, so I think of this as like I put an x minus 5 under a fraction. So let's let the outer shell just be 3 over x, and the inner layer be x minus 5. And again, could be different answers for that one, but that would work. All right, so that's everything you need to know about composition. Go ahead and try the homework, and if you have any questions, email me or let me know.